Assalamualaikum warahmatullahi wabarakatuh, and hi, welcome to my slide video presentation. First of all, my name is Muhammad Amirul Hafiz bin Jailan. I'm a final year student for Faculty of Mechanical Engineering, UiTM, Pulau Pinang. So for the final year project presentation, the title that I carry is Optimization of Solar Panel Facing Angle and Direction on the Performance of Solar Panel using RSM. Next, I move to the project background. The elimination and reduction of greenhouse gas is essential measure for global warming mitigation. Therefore, the use of PV panels have been used as a fast-cap component for power generation. Therefore, selecting and currently installed PV panel directly affect the performance of the device. Furthermore, DOE is implemented in solar system to forecast the behavior of current, voltage, and maximum power determined by the function of irradiation level and temperature. Apart from that, most of the researchers use temperature, irradiation level, and shading as the factors that contribute to the performance of solar system. However, there were no studies to optimize the tilt angle and direction under RSM implementation, which being a gap studies on implementation of performance of solar system. So for the problem statement here, first, less solar radiation received on PV panel surface due to unsuitable positioning of tilt angle and direction. Furthermore, the angle and direction can be optimized by solar tracker system. However, the capital cost of this system is much expensive and high maintenance cost. Also difficult of maintenance solar tracker system in remote areas, and altering the PV manufacturer's specification is insufficient to improve the performance of PV panels. So for the objective, first objective is to conduct experiment on the effect of PV tilt angle and direction on the gradient, short circuit current, open circuit voltage, and maximum power by implementing DOE. The second objective is to analyze and evaluate the interaction effect between tilt angle and direction on the output power performance, short circuit current, and open circuit voltage of PV panels. And the third objective is to optimize the performance of PV panel by identifying the affecting factors by using a response surface. Next, I move to the significance of the study. So the most significant of the study is the fill in the gap studies on optimize the tilt angle and direction. That study increase the performance of solar system under RSM implementation. Also, this study will benefit to the society to utilize the fixed PV panel instead of solar tracking system, which are more costly and high maintenance cost. Last but not least, the other researcher would know the implication of RSM towards optimization of solar system by taking PV tilt angle and direction as the factor used. So for the scope of work, so the data collection of response at Sagil Johor from 12:30 p.m. to 1:30 p.m. on the sunny days. The second is the experiment trial is based on the design of experiment, and the data will analyze through the analysis of variance. So the limitation here is the result of the study cannot be used for another location due to lack of experiment conduct to certify the validation of the study. Next, I move to the literature review. Many researchers have investigated the optimal tilt angle and direction in many places in the world, and I only focus in Malaysia only due to the local geography characteristic. So from Father Eneja in 2015, he said that the range of 10 to 15 degree tilt angle is excellent for receive maximum solar radiation at early location in Malaysia. And KR Ajo in 2013, the solar panel should face south direction for countries in the northern hemisphere. Since my project require RSM implementation, so from Saruhan in 2016, based on the second order model, an applicable model could be well constructed to correlate the response which lead to optimization. And for the design of experiment from Saruhan in 2016, the number of experiment trial depends on the number of center points and the number of factor used based on the CCD. And for the analysis of variance, the literature review is come from the 89 in 2014, where the model could achieve significant model at 95% confidence level when the p-value is below than 0.05. And this can be support from the R Sullivan in 2017. The predicted is close to observed value, while the R squared is close to 1. So this is the method that I use for the DOE. The numeric factors range was set from 10 to 40 degree on the tilt angle and 52 to 300 for the direction. Basically, 30 runs were generated based on the CCD implementation. So for the data collection, And I use a solar power meter, digital multimeter, and 50-watt solar panel. So for the value of maximum power, I use the field factor equation. Next, I move to the data analysis. The ANOVA is used to develop the predictive models and to identify the significant models, include the p-value, lack of fit, analysis of dynastic plot, and I can observe the response surface and the contour plot. So for the next stage is the optimization process, where I conduct the numerical optimization using the reducibility function, and it needs the confirmation runs at the same time at the same place, and compare the data obtained with the predicted by the RSM. So here is the design of assignment result. As you can see on run 2, 3, 4, 6, and 7, there were 5 vertical runs in DOE due to 5 center points. This can be described in CCD equation, where the number of experiments is equal to the number of azier points, the number of star points, and the number of center points. Also, you will observe at tip angle 25 degree and the direction at 176 is a facing south. It generates higher maximum power approximately of 45.61. So I move to the analysis of variance ANOVA. As you can see, this is a summary table for 4 models of in ANOVA. So, and all the 4 models achieve a significant models. And the model terms present A squared, and B squared for 3 models except for maximum power, which additional of A and B. For your information, A is the tip angle and B is the direction. And for the lack of fit, only irradiance achieve a significant lack of fit. It's because because the pure error was low compared to the residual error. Also, as you can see on the graph, for the 4 models, the data points were normally distributed on the straight line graph, and all the percentage error difference of model was acceptable. So this is the model graph of response surface and the contour plot. So based on my findings and my observe on the response surface and contour plot, the irradiance level approximately increased from 850 watt per meter square to 1,300 watt per meter square, as the T angle decreased from 40 to 10. And however, the irradiance level fall to 850 watt per meter square when the T angle 40 and facing direction on west and east direction. So I can say that the T angle of from 10 to 19 degree and facing south was the optimal condition to absorb high irradiance. Also, it also same for the short circuit current. The highest current, approximately of 2.9 ampere, generated by PV panel, was found at the direction south, southeast, and southwest, and in the range of 10 to 19 degree of tip angle. However, the current fall below 2.84 ampere to 2.2 ampere, as the tip angle increased from 26 degree and direction facing north, northeast, and northwest. So I can say that the optimal tip angle to generate current was approximately 10 to 19 degree and facing south direction. So this is for the open circuit voltage, response surface, and contour plot. So the highest open circuit voltage of 31.46 volt present when the tip angle lies between 15 to 26 and direction in the range of south, southeast, and southwest. However, and the open circuit voltage of 31.46 ampere drop from optimal area when that angle increased from 25 to 40. So I can say that optimal condition of voltage can be achieved by point the tip angle in 15 to 25 and facing south direction. Also, it also same for the maximum power, where the maximum obtained of 46.89 watt when the optimal area is situated in the range of tip angle of 10 to 26 and the direction of south, southeast, and southwest. Next, I move to the numerical optimization. As you can see, this is a ramp function graph of desirability. The ramp function of graph desirability show the optimal solar system facing condition of 17.46 T angle and 179 of 03 direction. The overall optimization process present high visibility of 0.977 of 1 and achieve 95% of confidence level. And I can cross-validate this result with a new post-analysis and new confirmation runs. And as you can see on the table, the comparison of obtained and predicted value, and the percentage error between this obtained and predicted value were approximately plus minus 1%, which can acceptable. So, as the conclusion, design of experiment has been successfully implemented on determining the predictive model of irradiance, voltage, current, and the maximum power, where the number of 30 runs was enough to obtain an accurate model. Also, the ANOVA successfully revealed that the main effect of tilt angle A, second order of tilt angle S squared, and second effect of direction B squared were the most influencing parameter on the response. And the lack of fit of irradiance show the significant value as the period was very small compared to residual error. Also, the optimal from the RSM, the optimal angle was found at 17 and 45 and facing south direction, where all the response was obtained by the 0.97 disability function opposed to 95% confidence level. And last but not least, RSM was successfully implemented to determine the optimal angle in direction to optimize solar system. And for the recommendation, I can say that the future study should be made with other experimental design, such as post-weekend, which involve high experimental runs and compare the result with central composite design approach. Also, another experiment should be made with various location, different latitude and longitude to satisfy the implication of this RSM study in solar engineering field. Last but not least, I also recommend to study on reducing the range of direction by focus on south direction only. I think that's all from me. Thank you for hearing my and watching my slide video presentation. Assalamualaikum warahmatullahi wabarakatuh.